morning, my dear students. Today we are going to start with, or we are going to continue our first unit, that is matter in our surroundings, and the basics means this is the basics unit. This is the first unit, and we have already covered a good portion of this chapter. Now today we are going to start with the states of matter. Now what are the various states of matter? First of all, we have the three common states of matter. We have the solid state, we have the liquid state, and we have the gaseous state. But there are two more, that is the plasma state, and then there is the Bohr-Einstein condensate. These are the five states of matter that are to be learned. Please remember these last two, because we do not study it in the earlier classes, but right now it is given in your course that you should learn these two also, and there can be good amount of questions in both of these. Means we can have a 1 mark question also, we can have a 2 mark question also from over here. Now let us study first of all solid state. We are going to study solid state today. For today we are going to only cover solid state. So let us see what is there in solid state. Now see students, solid state, first of all we should understand some of the examples of solid to make it clear that what is solid state. You know sugar, sand, iron, wood, rock, minerals, ice, etc. These all things are included in solid state. We know sugar is a solid, sand, iron, wood is also solid, rock is also solid. These things are there. Now let us see the basic properties of solid. These have fixed shape and volume. We know this thing, shape is also fixed and volume is also fixed. For example, you have a cube. Now this cube, if it is of stone cube, then the stone cube will have a fixed shape is already fixed over here, and we have the volume also fixed. It will not change. It is incompressible, means you cannot compress it from the outer sides. It will have very high density. You should remember this density relation, that solids have the highest density, then liquid, and then gases. They do not flow, means these are not fluids. In the previous class we studied that gases and liquids, these are fluids, means these have the tendency to flow, but solids are not fluids. They have fixed volume and hence their particles cannot move, because the volume is fixed. If this is the volume, so here all the particles are very tightly packed, so we will see that the particles do not have any space left for moving here and there. So because they are having the fixed volume, so the particles cannot move. Now let us see some of the common questions that can be asked from this topic, that is solid states. Question number 1 says that rubber band stretches. We know rubber band is stretching, so is it a solid? Now why this question has arisen? We know that the solids are incompressible, so they must be also inextensible or unstretchable. They must not be stretched, means if we cannot compress them, so we cannot stretch them also. We must not stretch them also. So that is only here that rubber band can stretch. Then why do you say that it is a solid? So please remember that rubber band stretches only when a force is applied on it, and if the new force is greater than the applied force, means there is a maximum force. Suppose this is our rubber band. Now there is a maximum force which it can tolerate to get stretched. After this, if a force greater than that force is applied, then the rubber band will break automatically. This rubber band will break if the force greater than its tolerating force is applied. Now you know that if we apply a pressure on here and here, you know when we will apply more and more pressure, one time will come that this solid will break. Similarly, this rubber band will also break. It shows that rubber band is a solid. The next question is, when we put salt and sugar in different jars, they acquire the shape of that jar. Why? See, if this is a jar and we have put here salt and sugar, and if this is a jar, here we have put salt and sugar, so here the salt and sugar will acquire this shape, but here they will be acquiring this shape. Means at one place they are like this and one place they are like this. Now why have they changed their shape? We already said previously that they have a fixed shape. Then how can they change their shape here in this cases? So what can be the answer? Now see, the answer is very simple. Salt and sugar are the wholesome quantities, means salt and sugar are made up of further smaller particles, and individual particles from which the salt and sugar are made are the perfect solid crystals. And that's why we say that we are not considering salt and sugar, we are considering a single particle of salt and sugar which is a perfect cube and which is a perfect crystal, means it cannot be compressed. Next is, a sponge can be compressed yet it is a solid. Why? Now see, sponge has solid particles, we know this thing, the solid sponge particles are there, but what happens is that between the two particles we have some air spaces left. like here also we have air space, here also we have air space, like this. So because of these air spaces we can compress the sponge, but it is a solid form. So this is the types of questions that can be asked from the general properties of solid state. Now let us start talking about diffusion in solids. Now what is the meaning of diffusion in solids? And first of all we should understand the meaning of diffusion. Diffusion is if a membrane is given and a particle is present in one side, then if it passes to the other side, it means that it is diffusing. The particle is diffusing. It means that from a particular site it is going to another place. From place A this particle is traveling to place B. It means it has diffused. Now this thing can be seen in gases, where the gases particles are free to move, so they can move from one place to another. It can also be seen in liquids, where the liquids have the free spaces to move from one place to another. But what about solids? Do solids show diffusion? So in solids it do occur, means the diffusion takes place, but it is a very slow process. Now let us see the examples where we see the diffusion in solids. See the first example. If we write on the blackboard with the help of a chalk, now we know that chalk particles are solid and blackboard is also solid. So we have, this is our board and we have written something on this. Now and if we leave it undisturbed for a few days, means you write it and then you leave it without rubbing it, you leave it there only for 20 to 30 days. Now what will happen is, after 20 to 30 days when you will come again to rub this chalk from the board, you will find that rubbing the chalk becomes difficult. Now why does rubbing the chalk become difficult or became difficult? It was because the solid chalk particles diffused into the blackboard. The chalk particles were here. This is the blackboard surface. After few times this particles diffused inside this blackboard, and because of that what happened was that it became difficult to rub the blackboard. The second example is when we take two metal blocks. Suppose we have this gold metal block and suppose we have here silver metal block. So we have gold metal as well as silver metal. Now gold metal is metal block A, silver metal is metal block B. Now what we are doing is we are just keeping them together. We are bringing these closer and we are keeping them together for a few years. Now what will happen is, after few years when you will again see them, they will be appearing like this. Means this gold and silver will be getting mixed together. Now you cannot separate these two. It means that the particles of gold from the solid metal had diffused into the particles of silver, and similar happened from silver to gold. So this is the basic topic of diffusion in solids. That's all for the day. Thank you and have a nice day.